So bad. More that is like that's project. I don't know. I think that's like great. I'm not on to things which you do. I see this. I am sure I thought it's like a personal. So yeah, it's not cheap and so to be with hours like all day exposure. So not I can one yeah. Genuinely think that would work.
Okay, so before we get started, okay, so is everybody, how's everybody doing as far as like previous two classes that I know that we forgot why we canceled it, but no, we didn't cancel it. Why we do it on recording? One of them is because my jury duty, but the ones before, I think we voted, right? In the end, we voted. Okay, but is there any question on those slides? Those are the one that I picked two are, one of them is about data structure, so it shouldn't be too much of an issue since you're working on that in your data camp, as well as that's kind of a review for data computer science, right? A lot of data structure class. Okay, so what about the second one with regarding data sets, KPI, and some of the data cleaning situation? Are we kind of clear on, data sets, right? Data sets is really, and KPI, right? What we are end up going to want to see on your presentation and on your analysis and on your Tableau will be the trend and or representations of your KPIs, right? But the data set is the data that you will need in order to get to those KPI that you're looking for. Okay, so you have to think about what kind of data it is that is meant for your project, like what your project is supposed to show, what your project is trying to do analysis. And those are the first step you have to think about is what data sets you want, right? And the data sets can, as a review, can be represented in multiple ways, right? It can, most likely for data scientists, data sets a lot of times is represented in a tabular way. So a tabular way could not only be maybe a SQL table, but it could also be an Excel or a CSV file, right? I mean, for someone who may not have any database experience before. And then the data set could also be in XML format, right? Not very common anymore, but it's still possible. JSON format as well, right? JSON format is the popular data set way for at least across different type of JavaScript or NoSQL database, right? But whereas KPI is something that after you clean and everything, you have some sort of index or some sort of already renounced key numbers or key ratios that you're maybe looking for in order to provide trend analysis for your project, right? Those are the things that you need to look for. All right, so with that said, today we're going to really, because we were cut short last time, so I'm coming back to what we talked about 3 weeks ago and what we ended, right? And that is for the API. Now, after this, we'll go really quickly again on just for those, especially for those who take a database class, and then we have a module today talk about database. It will be again go over some databases, data storage, and what it means for data science. Okay, and what are those commonality out there? Who uses what? Okay, all right. So I believe that your data camp class have you guys worked on Twitter API, right? But you guys are using you guys are proctored with data camp, but using wrappers of Twitter, not directly calling Twitter. I mean, imagine, right? So you're not calling HTTP directly, but that's okay because most likely for this semester, at least, you're probably going to choose Python for your project regardless, unless you're choosing Node.js and then you're using React or whatever, then you're using JavaScript to call JSON. That's totally fine too. JavaScript and JSON are and APIs are very compatible. Now, if you're using Python, you're probably using the same thing as you learned from Twitter API. The important thing is Twitter, the project, the data camp uses Python wrapper, right? So if it uses wrapper, it eliminates a lot of problems because you probably don't need to get a key. You probably don't need to get authentications and token and stuff like that. You just need to make sure and test out quickly and soon, if you haven't, with your team, that now those are available for your project. Okay, and so then let's come back to what API without the wrapper, okay? And we have to mention previously, we talk about different type of way to a different type of request, right? Just a review. So different type of request is that on behalf of a client, right? So a client is not necessarily I'm not talking actually the end user. The clients are usually the end user's interface, right? So which means it might be the browser that they live on. And that browser landed on, for example, a web app, for example. And that web app itself is sending requests. That web app, when you click on a button, it's triggering a request, sending that request through API to try to get some data back, right? Just to be, remember last time we drew out that entire system design picture, right? So the request is, in theory, coming from an end user, a human, but actual vehicle or protocol that request is fired up is by some trigger on the application in your browser, right? So the request for the client is a remote end from the server where the API lives, the endpoint where API lives. Okay, these are the most common one are get and post. Get, you're simply normally trying to get is a read. You just want to do something for reading purposes, read only. If you use a get request, this is a post request. A post request are very commonly used for two reasons. It's slightly more secure than get because get normally will expose everything in your query string. What is a query string? Meaning like after this comment, for example, you have a question mark and followed by question mark, you have a key value pair. Those query strings on top of each other. And those query strings is used for filter purposes, right? So you have a key and then you have a value of what filter that you're looking for. Let me try to look for an example what I'm talking about. Is there a one? Okay, so for example, take a look at this get method, right? After the headline, a question mark, country equal to US. So that's key is country, value is US, right? So that's a filter. I want to get the headline where it's from US. And then additional to country, I want a category to be science. I want basically US science, right? So this is a query string right here. Two different filter, you want to use a ampersand in between, right, to separate them. not, is it an ampersand?
Yeah.
Okay, ampersand, not a pipe or not a comma, right? So between country equal to US and category equal to science and API equal to blah, 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 you see there's an ampersand. That's how you would be able to include multiple filter. And in this case, multiple key and value pair, right? And this key and value pair is to say to your API's provider or your data provider, which is the endpoint, that hey, I want under your headline data or results or all the JSON data that there is from your headline endpoints, I only want country equal to US, category equal to science. And my API key, behind that API key is not a filter anymore. That is actually the token that you have of yours, okay? Now, you can see for two reasons. It is exposing not only the filter, but it's also now you're having the API all over the place, right? So a lot of time, a more graceful way, even though if someone is still trying to just get read-only data, is by resorting to using post. Okay, I don't know why it's so hard to get post. Why? Because post, you see the query string here, which is still, we're still talking about requests. So this is the data you're trying to pass to the endpoint. Here, you can see that the body here, what you're including is your filter, right? And look at now it's being encapsulated inside parentheses and looking like a JSON format, right? So this is now in the body instead of on the URL. That would also include the API key and all that stuff that you're trying to pass as a GET, but rather it's more organized as well as secure or more private in a sense, okay? But GET, however, is still the most simple, common way to get data. If you just want to get data to read only, where POST could be used to add and read and other things. Even POST can basically do a lot of things. It could also do update, right? But it can do so many things, but normally posts are just used for, if you imagine your endpoint or the server has an array or a list of data, and post over, if it's successful, it would just add another object to the list or add another row to the database or the table, right? It's to add, but it could also use for read purpose, okay? Now, other method we also touched about that you can take a look at here if you don't remember. Okay. Really make sure that you know each line here, you see each slash, like backslash, all in here. These are, first of all, you see the first one is domain, right? With blahblah.org. That's the domain that we know, right? That's where the server address is, right? You see the V1, a V2 over there? Okay. V2, V3, V1, a lot of time come after the domain, or maybe even after one subdomain, okay, whichever comes. But these V1, V2 indicates that if you use this API to get data, if you are an API consumer, right, a data consumer over API, and which a lot of places do these days. Like I can't think of places that don't do this. You are bound to be responsible to update or to reconcile or upgrade your code or to handle your data when they are new versions. So normally the way it will work is if I'm a data provider, I'm the endpoint, I'm the server, right? I give you this API because, there's probably data that I'm going to send over. This V2 and stuff would normally, the way it will work is I would probably say that, hey, just a heads up, we're testing version 3 now. Or on their website, they're probably going to announce that, okay, we'll have version 3 or version 4 now. And initially, there will probably be like, hey, if you want to be on early testing, here, use the V3. And the developer that is consuming those data will start testing it out and see if it breaks their own code, right? They will start using a test. If there are early bugs, they will get on the testing code, V3 version testing code, right? And if they don't, eventually the version, the data point provider will say that, okay, now our V3 is officially live. However, we are going to still let you go and test your code, and we'll still keep the V2 lights on for like maybe another 6 months. And then we'll going to tell you and remind you, all of these are if they're nice. If they're not nice, or if they're normally, if you're just telling public API, they would probably not care that if you're upgraded or not. They would just announce on their website, or they'll send you alerts when you sign up for the token in API. So they'll probably say that, okay, version 2 is going to live for another 6 months. But if you don't want your code to break, you should move to version 3 before this date. That's normally what this version here means. Okay? And a slight small tip, normally a breaking upgrade is by, like, you see this V2, if it changed to V3, that's normally in the industry, people would know that if it's the first number change, that's normally a code breaking upgrade. If it's like V2.1 to V2.2, it's slightly less risk. Slightly less risky. Okay, but those are just some like side note anecdotes. Okay, all right, so and I also talk about these set of code, respond body, and respond header. Now we are looking on the flip side. This is when we are now receiving back the response. Okay, so when the response passed back from your HTTP protocol to whichever library or programming language that you are receiving and you're using to receiving these response. These response usually are divided into these 3 parts: header, status code, and respond body, right? The header, the status code, we kind of went through the other day, that it just kind of give you a really quick heads up when you are parsing them, right? If you know if it's 200, right? Normally, if you're a good, I guess, API consumer or web developer, you will probably either use the library to gracefully catch using try catch to first get the status code, right? Because in the try, you can probably already get if the status code equal to this, right? And you can start handling what you're going to do about it before you start parsing. Like, because if you don't read the status code first, you could, but then you'll get probably in the response header or body some text telling you that there's an error out. But if you can use the number first already and then find ways to handle it using almost like a try-catch block, why not? So that's normally more gracefully what you will do is you will use these status code first and have a correspondence ways to handle what you're going to do next. So that's what a status code is meant for, normally for developer to know. And hopefully you don't display something like 404 directly to the end user, right? But let's face it, like 404 code, everybody's seen it before. Okay, respond header and respond body. Now, respond header, again, is normally includes like metadata information, cross-border information and maybe an error message information, right? That is short and sweet. It's normally more about these highlighting informations that slightly more technical, where the true value of your response for as far as the user wise is probably in the body, because the body will include what we call a payload. And that payload is basically the object that stores your JSON data. Okay, normally through API, you end up getting the data in the JSON format, and this will be included in your response body in the payload. Okay, and that body in the payload, it will still be an object. It will be a HTTP object, and then you will need to use some type of library or JavaScript to parse that object and JSONify it, and then you can read the JSON file. Like, you know how that works, right? Like, so for example, you guys both did JSON, Python with Java, right? So think about it's still a unserialized object, and you just need to serialize it using whatever programming language you're using. Or in other words, think about it as an abstract class. You still need to, I guess you need to, what do you call it? Instantiate it into a concrete class object in order to parse this data. So that's what you still need to do, okay? Those are kind of details. All right. So we kind of go through all of them. Now what we have left is to talk about, do we already cover WebSocket? No, not yet. We didn't talk about WebSocket. Okay, so let's look at a couple more APIs that they are. So we talk about the most common API one. Now, there is I believe the module team had mentioned about previously in the API sessions. Before we move on to other type of API, first and foremost, API is a very powerful tool, and just so we are all clear here, API a lot of time are used in cross domain, meaning like they're in different network or different company or different regions, and using API to pass data securely using HTTP protocol. Okay. Now, APIs, the characteristic of API is that there is a request and then there's a response. If there's no request, there's no response. So you see, it's a poll. This is called like a polling, right? This is a polling technique. What a polling technique is just opposite from push technique. And by push technique, think about push notification, meaning like you are subscribed to let the foreign end to send you without you asking. That's push, right? Polling is only when you ask. Okay, so we have the API RESTful service, which is the one that we talk about the most. Now, different type of API include GraphQL. Okay, so what GraphQL is slightly different is that to RESTful service is that GraphQL, what we've seen here before, this part, right? This is parameter that you're passing in the request. This is a RESTful service API, right? When you're calling a RESTful service, you can pass filter. This is filtered down. In other words, if you have here, can you guys just raise my hand so that I can choose how I'm going to explain this? Have you guys taken SQL database class before? Because you're taking it now. Okay. Anyone is not taking, ever taken before? Have you taken? You haven't taken. Okay. How do I? Let's see. Okay. Then I'm gonna use a data structure example. Okay, thinking about a list of objects or a collections of objects. So it doesn't matter what data structure it is. A collection meaning there's a multiple action. It's a group or a set of objects, right? Now, what this is doing here is that it's specifying that I only want the objects that matches these objects property filter. So inside object, there's all different property in there, right? Local variable properties. For example, if you have a car object, you might have a mirror property in there, right? And I said mirror, I want it to be tinted or not tinted, for example. So I only want the cars that has tinted mirror, for example, right? So this is filter on the property. This is reservoirs, right? So only the object that matches this filter gets to return. Now, the difference, what GraphQL had, the most different from GraphQL to RESTful service, is that it's not just about, they can do filter as well, just like what I mentioned, filter on the property, so return less of an object, they can do that as well. But in addition to that, you can only choose within an object what are the actual property you want it to return. Okay, so that's, for example, cars, there's a collection of cars, that's a Python or Java, whatever. The car is an object, right? A car is a class. And I have a collection of cars, let's say. And then today I said dot filter window mirror is tinted, right? Then I only get the car returned back with tinted mirror. But every single car, I will still get all the other property, including the mirror, it will still get like the car is white or like whatever, all the property that car object has. What GraphQL can do is that I can actually say that I only want the color of the car property to be returned. That's all the information that I want. RESTful server doesn't do that. Does that make sense?
QL, you can choose what attribute.
Yeah. Yes, exactly. Okay, so there's no the difference of these two are not hugely different, but GraphQL does provide on that where so that I guess the advantage of that is that it won't have to return so much data for you to parse. But at the same time, GraphQL, you obviously there's good and bad for it. So this is one of the good things, right? And then a lot of companies are starting to use it as well. But GraphQL are, at this time, still more popular amongst teams or application within the same company, like each different team talking to each other. Two reasons. Because in order to use GraphQL, you need to, in order to apply for the de facto API is normally RESTful service. So if you're trying to find a public GraphQL, it's not as common as RESTful service. So that's number one today. Number two is that both of the data host, which is the endpoint of GraphQL, as well as the consumer, you will need to learn a additional, almost like a SQL queries like language in order to communicate using GraphQL, right? So there's a slight learning curve that's slightly harder than RESTful service. And there's not as many documentation out there for GraphQL versus RESTful service. Okay, so there's pros and cons out there, but just because still realistically, what is more common today is still RESTful service, and because there's more documentations and all that stuff, and then just more commonly provided. And that's it. If a company don't have that much resources or that many developers, they'll probably write RESTful service first before they can write both. Okay, So I would say that these are some of the observations I would say between GraphQL. However, GraphQL is very powerful if by default, if a company choose to use Next.js, which is a framework in JavaScript, on top of React, to use GraphQL because I think that they are very integrated. Okay, and then Next.js has this very good, powerful, new web framework for especially for like marketing websites and stuff. Okay, like sales and marketing websites. Now, okay, so outside from RESTful API and GraphQL, so there are some that are pretty old, and there's one WebSocket that's still very different, unique. So SOAP, JSON, gRPC, XML, all these things I never used before. I actually used SOAP before. So SOAP, I use it while back in the days when I was developing using ASP.NET and C#. And then using the backend Microsoft SQL. And then SOAP is basically a way that ASP.NET will communicate with C#. So that's all Microsoft framework, sort of. That's how I use it, at least. It's not super common, but it's also not using JSON. It's using XML as the communicator protocol. 3, 4, 5, I have no idea what they are, but they're just different type of API. I never used them before. So I'll skip that. The WebSocket. Okay, so WebSocket is a communication channel, and then it's similar to API, but it's a both-way communication channel. So it is a API that has push feature into it, right? So the way the WebSocket will work is by agreeing on what kind of data that both ends are going to communicate with. So, for example, the consumer or part B or the person B and then person A, they will agree on, I want stock and the stock price data, right? Once that is agreed upon, and the data type that they're receiving, once that's agreed upon, they just open the session. It's almost like a live session on the internet. It's still through HTTP, right? And so within this time, the sender doesn't require the person who receiving the data a request anymore. So the data can directly come when there's a new available data that matches what the consumer wants, and vice versa. The consumer can send back data as well.
Like for real time data.
It is used a lot of for slightly simpler real time communication, such as Facebook chat and WhatsApp and all that encrypted. Yes. Now, at the closer to next or in 2 weeks, we will learn about streaming data. That's also another real time, but that will be more or so handling big data. That's also a live real time data. So WebSocket has this flavor of streaming, but it's not so much. You just have to remember that it is live. It seems like it's both sides. It's not waiting for some queue to send back data, like other APIs or RESTful services, GraphQL. It's bi-direction. So I can initiate data when I have it and I just send it to you. Okay? So it's used a lot in your Facebook Messenger, yes, for example, or anything chat related. Right? So basically, if you look on your Facebook Messenger or WhatsApp Messenger and you found someone that you're friends with, and then you create a chat, and that is an activation of the WebSocket session, right? And by default, they're agreed on, you will be sending media type or string type or whatever communication. And then anytime any side of the party can send that communication, right? Another example of WebSocket is also stock trading platforms. Stock trading platform, personal stock trading platform uses WebSocket as well. On your phone, for example, right? I'm not talking about like a big bank, their own trader, but more like a retail trading platform. Retail trading platform meaning like daily personal retail, like people, huh? Yeah, like more like to facing like everybody rather than like trader to trader, right? Okay, so they would get that just like what I mentioned previously, between 9 to 4. If someone's following or want to watch a stock, or like for example, I want to follow Nvidia, right? I will set that I want to get all the update whenever Nvidia price changes, which is all the time. And WebSocket is live, and it's good for that purpose. Okay. Third and last but not least, did I already talk about WebSocket? Are you sure I haven't talked about WebSocket?
You mentioned in a previous class.
Okay. Yeah, I feel like a little deja vu for some reason. But okay. Last but not least, one. If I had mentioned, what will be the one? If you guys remember.
You mentioned what?
WebSocket, another use case for WebSocket. A very common one. It doesn't look like WebSocket, but it's very common.
You said like activating like protocols or channels, so like they can like share information.
Yeah.
And also like API sends requests. I'm assuming like the server is the endpoint, so
Yeah.
the database is
Okay, so maybe I haven't talked about. Okay, so last use case that's very common in deploying WebSocket as a communication protocol is status updates. So if you have something that requires a long processing, and especially when you're uploading, for example, when you're uploading a video, okay? And these days, these are not necessarily that long anymore. But let's say if you're uploading like a very high quality movie of your own and you're a YouTube influencer, and then you are uploading that into YouTube. Now, just a side note, when you're doing that, when you're uploading to YouTube, YouTube doesn't just take all your movie of the whole 2 GB file and then store it on their website. They don't. What they actually do is similar to if you have Google Photo or any other photo albums in the cloud. What they do is that they're going to first convert it into a high definition, whatever, codex type of file that they themselves use, right? And it'll still be high level, but they first convert it because that would be helpful for them to store on their end, to distribute this data, whatever, and then encrypt it as well. Okay, so they do that. So in the back end, what you don't see is you're not only processing this data to whatever the YouTube cloud is, storing their data, but in the meantime, they're going to decode it. And then until they're almost finished, they also would show you a preview, all that, meaning like they're actually showing the screen of some of your movie, right? Like a screenshot of your movie that you're uploading. So it's actually all these things that are being done, and these are side notes, that it doesn't matter. The point here is when you're uploading this file, that status bar that tells you it's still spinning, still moving, still whatever, that deploys WebSocket in disguise. What it does is that it continuously from the server side sending information about a status, how much maybe still left or how much they're estimating. And so basically the backend just kind of keep on saying like, oh, every 5 milliseconds say if it's done or not, if it's done or not, I keep on telling you. And then the front end receive that and it's still spinning or it stops. So that's a little bit of side note on WebSocket, just in case if you ever face an interview and then that's a trick question to ask. How do I build a, like, you know, how do you call these things with the stand thing?
Like a loop.
The one that you flip and then it's like a timer.
Hourglass,
What?
an hourglass?
Is that hourglass? I don't know, like the one that looks like this.
Yeah, it's an hourglass.
Okay, right? How do you build that to like, see a status bar or like how do you build this thing?
Like a loading.
Yeah, exactly. Right? Normally the answer is that they're trying to seek you to call out what's happening. Okay? All right. All right. Here are some of the syntax that you guys can look at and what I had already explained before. It's all shown here. This is a very common and it's probably slightly outdated, not outdated, but like there's more nowadays, but this is a what they call Swagger IO. And this is where people who provide API, like the endpoint provider, normally come up here and then document their API. Basically, this is already a library on I think this is on Java, and maybe on Python too. There's a library called a Swagger. As long as your code is written in certain syntax and certain follows certain framework and rules, it will create this documentation for you. Okay, I will let you guys look at the example on your own. There will be some questions on API for sure, like just to ask you, are you aware what is what does what on the API when you do request and respond, and what kind of methods they are? But two things I do want to mention that are helpful tool is that if you don't know already, if you never called API before, a lot of time when you're building websites, you use Chrome or whatever other browser, but let's say if you use Chrome, if you pass F12, right, you get a console. Developer console, you press F12 on Chrome. It gives you a developer console. If you click on network and then go find one that has like 200 or whatever, 200 status code, if you tap on the network bar, let's see if I can find one needed. Press F12. I don't know if this one. Okay. If we're in network. Okay. Okay, well, this is like gibberish, but you can see, for example, this is okay, well. Let's see. You can see here, inside network, right? In the tab network, which is right here. You say see network right here. I tapped F12 and I go to network and I did this fetch thing right here. And then I click on this. Where did it go? Oh, the one that I click on. Oh, it's probably on the top. Okay, I got this one. This one I didn't get 200. I get a 404 anyways. But as you can see, this is an example. Look at request URL. It says right here a bunch of things. You see the google.com a lot, and then we're following a lot of get metadata equal to token equal to blah blah. You see that, right? And it uses what post method, right? And then it's status code comeback is 404 now found, for example, that I mentioned before, right? There's some payload over here, even though it's back, it's 404, it sends back all these error non-gibberish stuff, right? And this is where you will want, like normally if it's 200, this is where your JSON data will be living in. So I just want to tell you that a lot of time when you do testing, right? And Chrome is the browser that you test your website and etc. This is where a lot of developers will come in and trying to debug and stuff. Now, the other tool that you can use, because obviously to run API, you will need, again, like some Python code or whatever, or JavaScript, right? Or whatever library that you use in Java. Now, Postman actually serve as a platform that can directly help you parse. Like if you put your API URL query string with Postman, you can download it on the app on your browser. it actually help parsing that JSON for you. Okay, so it's a really good tool. Another good tool for you is that if I come to this page, for example, back to that wherever F12 here. Like, okay, for example, this is gibberish here. Well, it actually is probably in JSON format, but we're just seeing it like that because this browser is not reading the object correctly. You can download an add-on extension on Chrome called JSON View. Just JSON View. It's created by Chrome, I believe, and it will just literally make all this into a JSON with color code. Okay, so those are just some tips for you guys to know. Okay. All right, so that summarized with the API, and then let's take a really quick attendance right now, and we're going to go about the rest of today's lecture, and then hopefully, if you guys all have learned about databases, and then with previous module team, maybe we can go this quickly. And homework, is it on homework 5 now? 4. Okay, so homework 4 is due next Tuesday, right? So next week before class, or during the class. I don't know, but just next week, anyways. And I want to remind you guys that in 2 weeks, you will be doing the entire class will be presenting your plan, aka the pitch of your project, live to everybody, right? And more likely people are shy and not asking questions, but I will be asking questions. And I already for this class, if you go to the homework, or if you go to the group project pick link on your syllabus, I have all what I'm going to even look for, all that been documented. And I even have an instruction on what you should prepare for your midpoint pitch. Meaning that by now, we're close to, well, by the time you guys are pitching, is probably halfway through the semester. And by that time, if you don't want to have a fail on your project, you probably should do these and that. As far as your timing was, so you'll have enough time to do your homework, to finish it, right? Because, for example, we have the project since the beginning of the semester. But we learn about different type of skill set of how we are getting the data because you guys didn't know. But now we do know the data, and then we have some of the skill set. You need to start thinking about where those data lives, and as those data that you're looking for, have you gotten some of them already? Like, have you tested you're okay to get it? Okay. So not just thinking about getting it, but have you ever tried? Because now you have the API skill. Have you tried to get them as a team? Okay. All right. So my reminder is that is in 2 weeks, but start looking at that document within the group project link. Not group project link, the pitch link on syllabus, right? It has the instruction, and then you should look at it just so that you know what to prepare for. Okay. All right. So why do we need to specifically talk about database, right? Because not only it's bad for this semester if you come back to me and then use a CSV file, and then using the Tableau to get the data from CSV file, that would be terrible for you in your grades, in your team. But L in ETL stand for loading. and then E stands for extract, T stands for transform. And then the transform parts is by how you're making your raw data into clean data. How you make your raw data into semi KPI, semi-likely of KPI, and could be already full a KPI, right? From data set raw data. After the cleaning and transforming, etc. L, the loading part, means that how are you going to now design and organize these data so that it will store in a appropriate data storage that you want. And then this storage of the data will continue to collect the data that you have extracted and transformed from. Not only that, but you could also do analysis on them, right? Or you can start enhancing data from other ETLs, other extract and transform methods, right? The actual part of enhancing your clean data or your own KPI or your own data sets to get more context and content is another terminology we call feature engineering. Okay, so far this class, we've talked about data science and we haven't gone into anywhere about machine learning, but we know that data science and machine learning is in a grand chart, it's kind of intersect with each other, or it's maybe covered by machine learning a little bit. But data science is covering machine learning, maybe that, and then covering AI, whatever. But feature engineering and data engineering are some of the things that within data science are most popular to talk about. So data engineering is basically is the knowledge of ETL, right? And the different type of ETL design that you will use, right? And so when we're talking about big data ETL will be slightly different from our project, which is a smaller size of ETL, right? So for data engineering, they need to be more aware of how to design their systems or how to deploy different module and choose different database in order to match the amount of data that they want to process and also the type of analysis that they want to do or the machine learning that they want to train on. So the L part is the final stage of the ETL process at least, and then that stands for loading, okay? And normally the ETL, which is what a data engineering or a team within data science work on, and the product that they created with this ETL normally ends after L, is called the data pipeline, okay? And the L part, where the database that you're choosing, depends on the size, depends on the needs. Lots of time it will be named, not just simply as databases. It will be named as data warehouse, data lake, or data mart. Okay, it just all the other terminology depends on the size and depends on the company. Data mart usually are the smallest, and then often are a favorable name and describing a schema or data storage of collection of databases that is good to directly use it for analysis. Meaning like a data science can directly deploy their business intelligence tool using a data mart, right? Now, data warehouse is normally where a data lake first. Data lake is normally a gigantic size of these data collections. It would include hybrid of NoSQL, blob storage, Hadoop, like collection database, like NoSQL, SQL, all of them, maybe all together, right? As like a cluster of data. And normally that data lake, the word lake implies that it's normally sitting there and collecting data, archiving data. So it's normally what is being used live. So it will probably be some data that now no one is changing or updating and then park it somewhere. But that data not only being parked, but it's still kind of like in hibernation, doing some processing using other tools like Hadoop or Spark. Now, data warehouse is something in between data mart and data lake. Now, data warehouse is normally where those big data processing or in-memory caching, in-memory whatever doing, or recommendation engine, or social media recommendations, hashtag building, all those things happen. Normally attached with something called Spark, or their similar competitors. And that we'll come back to those later on. Okay, so data warehouse, data lake, databases, data marts too. It's not in here, but okay, and enable analytics, reporting, and machine learning, and other stuff. Okay, now this kind of went back to similarly what the team had before, so we don't have to kind of. Is there something that we haven't really? We talk about especially the scaling, so we're gonna skip that. The asset property and base property. I think that if you're taking database courses, you're probably gonna hear about the asset. I don't know about the base, but asset property just means that relational database. They have the whole reason why relational database is more secure is that by default, these relational database, not only that they're displayed in a tabular fashion, like tables and tables, and between these tables, they have relationships so that the data doesn't get sort of out of context because they have relationship between tables, but also it comes with SQL, like its own query language. But it's normally when you're at the bottom, when you come down to choosing between NoSQL and SQL database, outside of resource, outside of your purposes, it comes down to security purposes. And when I mention security, it's not like privacy and stuff. Well, yeah, it is also privacy, but more security is in a way of accuracy. Okay, what accuracy when it comes into play for relational database, SQL database also, they're also known as transactional database too, if you are curious, is that SQL database provide this transactional framework, meaning that you can have multiple SQL select, create, or whatever function within one transaction. Think about it as a try-catch blocks. All right, in try, you have a lot of calling, right? When you're coding try-catch block, right? So in transaction, you can have all these SQL statements and querying and stuff. And this transaction will say, like, when someone's running this transaction, everyone who's within this transaction, whichever table is being called, whichever column is being used, we're going to lock it down. So no one can update it or no one's going to read it until this transaction is finished. Right? So it has this like proper way of saying like, I am not going to be getting a data that is currently being updated or is still not finalized, right? And secondly is this transaction also have this similar to try-catch block where it has rollback mechanism. If it failed in part of the transaction, it will roll back as it never happened. So this asset property is really just echoing to this transaction, which is unique to relational database. Versus with NoSQL database, number one, NoSQL database, they don't lock a transaction because they prioritize on availability, which means speed, meaning like for their what they care more and people choosing NoSQL, and a lot of time why social media or sales and marketing does choose that is because they figure the user care more about usage rather than accuracy. Meaning like when they're on the app, they care more about its working rather than how much lag their information is. Like a minute, 5 minutes lag is not as important to them. So they prioritize the speed. So meaning that they don't have those locks like you think that SQL does. So they will provide you what they got first or whatever they have, even though they might be still updating. But eventually, however, eventually they will still get accurate at some point. I mean, the database essentially, eventually, they're all going to get synced up and get updated. But it just, do they prioritize on locking so that the accuracy comes first? Or do they prioritize on, okay, well, we can share, we can kind of like have a balance and kind of all mutually agree that, we'll give you something that is not too out of line. Okay? And in addition to scaling situation, and in addition to the first parts with the fixed schema, flexible schema, because like early on, as they mentioned, the module mentions, when you are trying to updating a columns in the table in SQL, you actually have to go and say, this table, I want to change a column, add, drop, change name or whatever in the SQL database. Whereas there's no schema, sort of, there's not such a rationale as a schema or like a table in NoSQL. So basically, you just add. You just say that, okay, this key value attribute, this key, I want to add another value in there. Within a value, I just want to add another data inside. So that's what all these are talking about. Okay? For your project, though, I don't care if you're going for MongoDB or MySQL or PostgreSQL, I don't care. But to be quite honest, like there depends on if you're super familiar and have a preference with NoSQL. But honestly, for any college project to use, like SQL would not have any scaling problem for you guys yet, because it's not that big that you will have to face any problem with scaling. Okay, all right, we can skip all these. Okay, so as far as in data science and ML context, right? So we mentioned about SQL, we mentioned about feature engineering we just talked about, right? So because the way that is structured data, so when you have two SQL databases, or when you have two schema design from two different ETL that comes into one, let's say data lake, whatever, or data mart, right? Because the way that is structured, it enables such more flexibility for your data to be enhanced by other people's data. Because it's easier to understand, where NoSQL is easy, fast to get, but it's not as organized for you to say that, okay, simple as SQL joining, and when I just want to get these enhancements from all the all the column from this table, right? As SQL, in NoSQL, you need to find each individual object. And you don't even know each individual object itself has the data that you're looking for, right? So enhancing feature engineering is preferable using using SQL database. And then you have the aggregation and join and all that stuff. Again, this is all part of feature engineering that you can think of to add up, aggregate, changing, getting more context. That's what joining, aggregation, those are for, right? When you're saying, tell me ranking, or tell me the max and min, it's easiest when you do it in SQL, right? Because they have commands to do that. You can group by a bunch of names, a bunch of columns within SQL. Then you can do easily, you can count them, you can sort them, right? And you can average them, you can sum them. Okay? NoSQL is slightly difficult because you're parking them once you find them, you will probably use the library, whatever tool you got. Okay, depends on the purpose of your machine learning. I think that at some point, machine learning will benefit from, let's say, when you're doing training and when you're doing validations, it will benefit when you are doing a supervised machine learning. And we'll talk about what supervised versus unsupervised. When you're doing a supervised machine learning, it might be beneficial when you're doing NoSQL, when you're doing a SQL database, because you kind of have certain amount of framework that you're using to train your data and test your data validating. Where you truly, when you want unsupervised machine learning or machine learning model, it might be preferable for NoSQL, just so that you get slightly more of unstructured, randomized data, taking away sort of like the human side of training. Okay, and also, when machine learning these days, a lot of different models came in about a place using both supervised and unsupervised. So therefore, hybrid of selections of database is often deployed. Okay, I'm gonna really scan through these. These are just for you never seen SQL before. These are some of the most common querying keywords, and especially for data scientists, right? I think the data scientists aren't not necessarily the one that create tables, inserting data per se, but they definitely more so read these data using select query, right? Select is what you use in SQL to read data, and within select, you would be able to filter using where clause, and you will be able to sort them using order. Okay, and then from, join and join from is where you will choose the schema or whichever table that you want to get the data from, or the database from. Join is when you are accessing multiple tables and then you want to combine the table to get the results. This is the part of feature engineering. And then there's different type of join. So I'm not going to go into detail, but these are some high level. Now, earlier I mentioned about the easy, already out of the box functions are some aggregations such as count, sum, and average, group by for still in SQL, and having, where you're able to filter after aggregation. Okay, so these are some examples while you will use SQL for your data science task. Now, for NoSQL, based on your choice of databases, there aren't a standardized language like SQL, but there are mostly common way of accessing these data by using either API or using your programming language that can read JSON. Okay, because most of them will be created like JSON, except for like Cassandra. Cassandra actually you don't have to memorize it, but Cassandra is actually being known as a Y column NoSQL database. And Y column NoSQL database is also known for it's basically a hybrid between SQL and NoSQL today. So it has relational modeling in there, but it also can be seen as a NoSQL database. And then the querying language of Cassandra is kind of like SQL. All right, so again, you will use Python or JavaScript to access these data for a NoSQL database, but essentially the data sets that you will get back normally are in a form of object where you can parse into JSON. Okay, so this is what we earlier on talked about with the JSON, how you would use Postman to get post requests and then try to read the response. Last but not least, the Docker. Okay, why would the Docker be sort of, which I brought up and the team brought up, why would be a good suitable candidate to really try to use if you have the time as a team? It will really be all the benefit for you. Okay, and I think that will summarize our session today. Do you guys have any questions? If you don't, I think just team 4, module 4 and 5, the one that you're presenting next week, just make sure that you guys are creating a team private group, including me, on Slack. Okay, that's it. Module 4 and 5, remember to do that.